And under this concentrated milk products, sweetened condensed milk. So I forgot to tell you that this is the one thing. Now this is the induced lactose crystallization. Now the crystal growth rate depends on the many factors. Crystal growth rate depends on many factors. One is the solution temperature. Other one is the second factor is the stirring intensity, agitation, the stirring intensity. And third one is the presence of impurities. Fourth, viscosity. And the fifth factor is the degree of supersaturation. Degree of supersaturation, viscosity, presence of impurities, stirring intensity, and solution temperature will influence the crystal growth rate. So then the next we'll move on to this, the next uh, uh, dairy products. Those are we call as the cultured milk products. So cultured milk, basically the curd, yogurt, cheese are the main cultured products comes under this category. And there are, in addition to, there are other product like the sour buttermilk, acidophilus milk, sour cream, like, or even the cultured beverages we can categorize under the cultured milk product. So before we move on to this, the different products, we'll discuss principles of the cultured milk product. So what is the principle behind this, the cultured milk products? So specifically the cultured means we introduce the bacteria, beneficial lactic acid bacteria into the milk, fresh milk, into the milk. So then fermentation is taken place. As a result of that, the liquid milk curdle and it forms some curd, or the coagulations are taken place. As a result of that, it make it a curd. Curd is, we know that is the fresh milk is in the liquid form, and once it turn into the curd, it is a semi-solid state. So the curdling is the process because of these cultured organisms. So coagulations can happen, that is called the curdling. Curdling occurs in a few ways. There are different curdling process. One is we call as heat curdling. Second curdling method is the acid curdling. Third one is the enzymes curdling. And the fourth one is not in any products, but it's called the age gelation. Age gelation. The heat curdling does mainly in the yogurt, or sometimes in the other products also be possible. But acid curdling in almost all the dairy cultured product. But enzyme curdling, not in yogurt or the curd, but also it's happening in the only in the cheese manufacturing process. So what is heat curdling? Heat curdling or heat coagulation. So it's basically heat curdling means now it's really the heat denatured the whey proteins. Whey protein, we know that in the milk, the different kind of proteins were there. Casein as the whey protein alpha-lactalbumin, beta-lactoglobulin. So the whey protein will denature. So then the denatured whey proteins when interact with the casein. So denatured whey protein will react between the casein, specifically the casein, the kappa caseins. At the boiling point, so the casein micelles irreversibly aggregate. Casein micelles are irreversibly aggregate. Their structure is denatured, altered, lost their original solubility at the boiling point. But on heating, buffer capacity of milk salts change and carbon dioxide released, organic acids are produced, and casein phosphate precipitate releasing H ions, that means acidic media. So normally the heat and acid coagulation, we can recover 90% of protein. 90% of protein we can recover because of the heat or the acid coagulation. But in the case of this rennet coagulation, in the cheese, only 76-78% of protein can be recovered from that. So therefore, the heat coagulation, now you can see what's really happened on this heat coagulation. This is the whey protein. Now, this is the native state of the whey protein. Native state is a folded like, and unfolding can happen because of the denaturation. Because of the heat treatment, the whey proteins, especially beta-lactobuline like things, they denatured. Once it denatured, you can see the structure of that, and the SH groups were there in the either side of this helical, now the whey protein structure. And so what will happen because of this whey protein, beta-lactoglobulin will denature. So then once it denatured, so it will bind with the kappa caseins. In the casein micelles, the hydrophilic casein is a kappa caseins, and from the SS sulfur-sulfur bonds, now this denatured beta-lactoglobulin will bind through this sulfur bridge into the casein micelles. So then the casein, kappa casein adheres to beta-lactoglobulin during denaturation. Because of the heat treatment, the denaturation is taken place. As a result of that, now the beta-lactoglobulin will bind with the kappa casein through the sulfur-sulfur bonds. Now, as a result of this, we can see the small coagulation is taken place during the heating process. Second most common curdling is happen in the acid curdling. Now when you take the fresh milk, the pH is somewhere around 6.5 to 6.7, 6.8, 6.7. That is the normal pH of the fresh milk. So now the main carbohydrate present in the milk is lactose. And the lactose, because of the fermentation, now we introduce the microorganisms, favorable lactic acid bacteria. So the fermentation is taken place. As a result of the fermentation, lactose will convert into the lactic acid. Lactic acid, it is a kind of acid. So therefore the pH is gradually declined from 6.8, 6.7 to somewhere around 4.6. Once it reaches the 4.6, it is isoelectric level. So then the casein micelle is a large complex molecule. I just explained it a few early lectures, the casein micelles. So then once the acids are formed, dissolution of calcium phosphate is happening that, because in the casein micelles, the calcium phosphates are there. Because of that, the submicelles are bond with the each together. Submicelles bond together because of the calcium phosphate. Now dissolution of calcium phosphate is taken place as a result of these acids, and then the calcium will release it, as well as from the casein micelles. Now submicelles are released. From the casein micelles. Now this is the casein micelle. Now you can see this is the calcium phosphate. Calcium phosphate is there. Now this single molecule is we call as a submicelle. Now kappa caseins are hydrophilic. That's why it's in the outer. Is kappa caseins are there, but other caseins are hydrophobic. So they are in the middle of that. So the calcium phosphate dissolution. So then the submicelles are released. These submicelles, as well as the calcium will release it. Calcium. And the submicelles and the calcium ultimately form the calcium caseinate. So therefore, because of that, the coagulation or curdling happen. This curdling is we call as the acid curdling. Now this is the structure of casein micelle, and these are the submicelles. Red color ones are the kappa casein. Those are hydrophilic in nature. Hydrophobic caseins are in the inside of that molecule, and protruding chains, the peptide hairs were there, and calcium phosphates in the middle of that. So this is happening the acid curdling. Now this is the kappa casein. So kappa casein sites are available even in the heat denaturation. Now these submicelles are released. Calcium phosphate also produce the calcium. Calcium will bind with the submicelle, and that is calcium caseinate are formed. Then the curdling happens in the acid curdling. Now generally in the casein micelles are the negatively charged casein micelles. Now this is the casein micelles, right? Now it's negatively charged, and heat Normally the casein micelles, we have heating at low pH levels. So it's just like this the casein micelles, and heating at a high pH. Maybe pH is greater than this 7 or above that levels. So then the whey proteins, denatured whey proteins will release it. Whey protein is there, whey protein denatured ones are there, denatured whey protein. But in the lower pH, denatured everything is together. But these casein micelles are negatively charged. But because of this acidity, acid curtain, acids are formed. If it is negatively charged, what will happen? The repulsion is there. Repulsion is there in the negatively charged molecules. But because of this acids are formed, now H ions are there in the medium. So therefore, because of the H ions, now the casein micelles will attract together. Casein micelles to attract together, and it forms the network. The network formation is there. So that's why it make it a curdle effect is there. The coagulation is happen. Caseins, because of the H ions, this now it will attraction is there. Otherwise, the caseins are negatively charged and repulsion is there. But now, during the acid curdling, lactic acids are formed, acids are there. So then, now the casein micelles aggregate, attraction is there, network are formed. Here you can see negatively charged, and pasteurization, the denaturation, beta-lactobulin will bind with the kappa caseins, and then acids are there, acid. So then what will happen? These positive charges were there, so therefore the coagulation is a network form. This will happen in the casein. Third curdling process we call as enzymatic curdling or enzyme coagulation. Now the most common enzyme is we use is the rennet, or we call as chymosin sometimes, or rennet enzyme. And this curdling process happen only in the cheese, because now during the cheese manufacturing process we use the rennet enzyme, not in the yogurt, not in the curd, not in the other dairy products, but in the cheese we use the enzyme rennet. Now here only this the enzyme coagulation is taken place. Now enzyme is rennet. Now what will happen because of this enzyme coagulation? We know that the kappa casein is the major casein, and kappa casein is consists of nearly 169 amino acids, 169, and the bond between the 150 amino acid, that is uh, phenylalanine, and 106 is the methionine. It's easily accessible to proteolytic enzyme like rennet. 105 and 6 bond is easily accessible. So therefore, because of this enzyme, enzyme will attack this bond and split kappa casein chain. So then the kappa casein is mainly made out of 169 amino acids. Now the in between 150 and 6, so the bond is easily accessible to enzyme. Because of this enzyme, proteolytic enzyme, now it will split into the two parts. So kappa casein molecule with 106 to 169 amino acid we call as the glycopeptide. It is soluble and released into the whey. It is about soluble and released into the whey. But in the case of this kappa casein molecule with 1 to 105 amino acid, it's insoluble and remains in the curd together with the alpha and beta caseins. So this part is we call as the para-kappa casein. From 1 to 105 amino acids, we call the para-kappa casein, and 106 to 169 we call as the macropeptide, or we call as the glycomacropeptide. Now, what will happen is the para-kappa caseins are there and the macropeptides are there. These macropeptides are water soluble, para-kappa caseins are water insoluble. Now, this calcium is there in that presence, and this calcium will bind with the para-kappa caseins and it forms a clot or the gel. This is called the enzymatic curdling. It makes it a network, and this is we call as the enzymatic curdling. Okay, therefore the three curdling ones. One is the heat curdling, second one is the acid curdling, third one is the enzymatic curdling. And the fourth one is the age gelation. Age gelation not happening in the product, but it's age gelation is an aggregation phenomenon that affects shelf-stable sterilized dairy products such as the concentrated milk and UHT milk products. So what will happen because of this age gelation? After weeks to months storage of these products, if you store these products for a week to months, there is a sudden sharp increase in viscosity. Viscosity will increase it, accompanied by visible gelation. So not only the viscosity will increase, but also the visible gelations and irreversible aggregation of the micelles into long chains, forming a three-dimensional network. So that means maybe after weeks to months storage, especially the shelf-stable product like sterilized dairy products or concentrated milk and UHT like product, there's a sudden sharp increase in viscosity. Sudden increase in viscosity accompanied by visible gelation. Visible gelation is there, and irreversible aggregation of the micelles into long chains forming a three-dimensional network. But the thing is, actual cause and the mechanism is not yet clear. Actual cause and the mechanism for this phenomenon is not yet clear, but there are some theories exist on age gelation. One is proteolytic breakdown of the casein. Because of proteolytic enzymes, the breakdown of casein. So bacterial or native plasmid enzymes that are resistant to heat treatment may lead to the formation of a gel. So that will proteolytic breakdown of a casein is taken place because of the bacterial or native plasmid enzyme. It's a proteinase enzyme plasmid present naturally native in a milk, present in a milk. So because of these two reasons, bacterial or the native plasmid enzyme, so proteolytic breakdown of the caseins, we call the result, as a result of that, gel formation is there. Second possible reason is the chemical reaction, especially polymerization of casein and whey proteins due to Maillard type or other chemical reactions. Maillard type reactions or the other chemical reactions. Polymerization of casein and whey proteins are taken place. As a result of that, age gelation can happen. Those are the theories. Third theory is the formation of kappa casein beta-lactobutyric complexes. During the heat denaturation, so this kappa casein beta-lactobutyric complexes are formed. Because of these complexes, now age gelations can happen. That's how the scientists, they explain it, this age gelation. So the main cultured milk products are the curd, yogurt, and cheese, and the beverage production, beverages. But we'll see one by one. Before we move on to that, what's really happened on this because of the fermentation. Now, this is a cultured type of product. Once the favorable like LAB organisms are introduced, the fermentation is taken place. So because of the fermentation, so the changes happening in the food sample, in the milk or whatever. One is the partial conversion of lactose to the lactic acids. Yes, LAB organisms, the main carbohydrate present in the milk is the lactose, then it converts lactose into the lactic acid. Because of that, as a result of that, the decrease in pH is decreased. And as a result of this, even the microbes, sometimes you know that the different volatiles are released. Different volatile compounds are released. Acetoin, maybe the carbonyl-like compounds, because of the LAB. You can remember heterofermentative and homofermentative organism we discussed. So then these organisms have the ability to form this. Earlier we discussed these homo and heterofermentatives under food microbiology. So then their type of organisms have the ability to release the volatiles. Growth of starter bacteria. Yes, we introduced the starter bacteria, LAB organisms. They utilize these nutrients and their growth is occur. That's a growth. Aggregation of proteins and formation of a gel network. Yes. Now casein is there because of the acid coagulation is possible now. Casein misses negatively charged one. Now because of this H ions, now it will attract and form the gel network. Those are some of these changes. And the other changes, slight proteolysis by starter bacteria is necessary for growth of the starter. Yes, certain bacteria, we know that two types of bacteria commonly used in the yogurt manufacturing process. One is Lactobacillus bulgaricus and Streptococcus thermophilus. So Lactobacillus bulgaricus is more proteolytic than Streptococcus thermophilus. So therefore proteolysis can happen slight by starter cultures. Casein is the principal substrate, but whey proteins may also be proteolyzed. Proteolysis can happen even in the casein as well as the whey proteins. So as a result of that, high levels of peptides and free amino acids in a fermented milk. So free amino acids are there, high levels of peptides are there in the fermented milk, high levels of peptides and free amino acids. So once the proteolytic lysis happen, and then the increase the protein absorption. We know the partial digestions are there placed, the meat diets and other things are formed. So then increased protein absorption is possible. And the first product is we call as the yogurt. Yogurt. What is yogurt and the curd? Both. So it's a semi-solid fermented milk product. But in the curd, the origin of this curd is not known. We just believe that it started from the Middle East or Asia, in the Asian countries, maybe several thousands of years ago. Origin of yogurt, they believe the Turkey or Bulgaria or the Mesopotamia, and in the 8th century, initial name was the yogurt, but the name with the change in 11th century is the yogurt. So these are very important, yogurt and curd. So why is it important? Now we know that these are very important because it has act as a digestive aid, facilitate the digestion, because which contain almost all nutrients are there. It facilitate the digestion. That's why. So and provides the probiotics. Yes, probiotics are there. Most of the LAB organisms are probiotic, even the bifidobacterium. The yogurt, sometimes purposely they add the probiotic organisms. So even the yogurt cultures are probiotic. And even these products are provide prebiotics. Prebiotics are the products, the partial carbohydrate-like product. So which support the growth of this probiotics, is a food for probiotics. So sometimes the oligosaccharides are there. And yogurt and curd is a benefit for lactose intolerance people. So they're normally the milk which contain lactose. So, but this because of the microbial actions, lactose will convert into the lactic acids, like thing. So therefore, the benefit for the lactose intolerance people, and easy to prepare. So this curd and the yogurt is very easy, even in a household level, we can prepare it. Has extended shelf life. We know that the curd may be nearly 3 to 5 days, sometimes maximum 7 days under refrigerated conditions, but it's somewhere around 3 days. So, but in the normal milk, it's only few hours. But yogurt, nearly 2 weeks. The shelf life is 2 weeks under refrigerated conditions. But certain yogurts, so 1 month. If you add some preservatives, so then 1 month is the shelf life. So extended shelf life. And value-added product. Value addition is there. So during this fermentation, now lactose will convert lactic acids, and the proteolysis is there, so the peptides are there, then the amino acids are there, then the lot of value additions are there. Even during the process, we add different other ingredients also. So value addition is there. So that's the value added product. Curd production. The first one is the curd. So we can use the different kind of organisms in the curd manufacturing process. And combination of bacteria like Streptococcus lactis, Streptococcus diacidilactis, Streptococcus primoris, and Leuconostoc-like organisms we use for this curd production. This is the multiple organisms we use, all LAB type of organisms, and different kind of organisms as I mentioned. So we can use those are mesophilic organisms. And the procedure is the manufacturing procedure of this curd is we have the manual filtering. So then the heat treatment. Heat treatment is we have to heat 95 degrees centigrade for 30 minutes. So during this, the heat treatment, even in the yogurt and the curd, milk, initially we just give the heat treatment. So there are many benefits from the pasteurization, the heat treatment. One is we destroy other organisms present in the milk. Once the organisms are killed, there is no competition for the nutrients. So there is no competition. And during the heat treatment, it creates microaerophilic environment because most of the LA-based yogurt cultures are microaerophilic organisms. So therefore, it's create a microaerophilic environment. And another thing is during the heating, we inactivate the immunoglobulins. Immunoglobulins, you know that it's a kind of a whey protein. Immunity comes because of these immunoglobulins. If the immunoglobulins are there, the other organisms cannot survive. So therefore, we have to inactivate immunoglobulins. And heat-induced coagulation is possible. Another thing is while heating, it will release free sulfhydryl groups. Free sulfhydryl groups are very beneficial for this LAB organism, for their growth and survival. So that type of advantages are there. And as I mentioned, then the heat treatment, so it's very useful, but generally 95 for 30 minutes. And then the homogenization, if you wish, you can have the homogenization, but some manufacturers, they don't do the homogenization. But once it homogenized, even the cow's curd, which will resemble whitish color, but generally cow's curd, it's a slightly yellowish in color. Only the buffalo curd is whitish in color. But after homogenization, even cow's curd also whitish in color. And then the production, the incubation. So normally the incubation means now after heating, so then we had to bring down the temperature into the normal around 40 degrees, 30-40 degrees. So then the inoculation we had to done. So then there might be somewhere around 32 degrees. We had to add the 2% of culture, and we had to stir thoroughly. So then after mixing this culture, we can pour it to the pots. Oh, some people, what they do, even they just the homogenize or heat treated milk directly, they add it into the clay pots or the plastic pots, and then after that they add culture separately. But even initially we can add the culture, and we have to stir it in thoroughly, and then we just pour it into the pots. And incubation is overnight in the room temperature. We have to overnight incubation. So then after the overnight incubation, so the curd is formed, then we can keep it in a low temperature. So the curd flavors are different kind of flavor compounds are formed because of the LAB, diacetyl, acetaldehyde, and similar compounds, ketones. So those are contribute to aroma and flavor. Those different flavor compounds. So this is the buffalo curd production. This is the heat treatment, 95 for 30 minutes or sometimes till up to 1 hour. Clay pots, they pour it to clay pots. So cooling to incubation temperature around 40 or 30-40 degrees. 40. Then we have to add the starter cultures. Starter culture. Either we can use the commercial preparations, or sometimes we can use the previously prepared the curd. We can take it as the starter culture. Day old pot. Previous day prepared the curd pot. So then we can take it as the starter culture. and then they incubate in the ambient temperature overnight or 24 hours. So then they can store it. Now this is the buffalo milk, heating, pour it into the clay pots, adding starter cultures. So keep it overnight. So then you will have the curd, buffalo curd or cow's curd also there. Now, when you take these requirements of curd for curd, Sri Lankan standards, they specifically mention cow's curd and buffalo curd. Milk fat should be the minimum 5 in cow's curd, buffalo 7. Milk solid non-fat by mass minimum 8.5. pH of the product is the maximum pH is 4.5. Maximum 4.5 pH. And the microbiological limits, now you can see it's according to this 2-class and 3-class attribute plans. Coliforms, number of samples 5, non-conforming units 2, lower value of the microbial 10, a maximum 100. Staph aureus coagulase positive, again number of samples 5, 2, 10 and 100. Yeast and moles 5, number of samples to be tested, and non-conforming 3. Lower value of organism count is 50 and maximum 100. But E. coli is negative, no E. coli, and Salmonella also absent, and Listeria also absent in the product. So then the next, the dairy item is the yogurt. So normally the basic types is we call as the set yogurt. It's a very common. It's commercially available yogurt. Nice coagulation is there, semi-solid. Other one is the process of stirred yogurt. The set yogurt, we know that the incubated and cooled in the final package, characterized by the firm gel-like texture is there. The semi-solid texture is there. And the process of stirred yogurt, so that's blended with the various ingredients. Sometimes the stirred fruits, cereals, and nuts, or cream pie, or chocolate-like things will mix together and provide strength, flavor, and color. And the stirred yogurt, the final coagulum, after making the coagulum, it's broken by stirring. Just sometimes if the stirring is severe, we can produce the drinking yogurt. But here is the stirred yogurt is broken by stirring, but not much. Then cool and packed. Texture is less firm than set yogurt. So a slight reformation of the coagulum. If when you drink it, even you can see the stirred yogurt, sometimes the coagulum partially reformations were there. So it's available in the bottles, like things. Now this is the composition of this the set yogurt. Later on I will explain why fat is 0.1 to 3.5. There are non-fat and moderate and the normal yogurt. That's why the levels are 0.1 to 3.5. Process also same. And lactose content is 3 to 4.5. Milk solid non-fat is 11 to 18. Stabilizers, most common stabilizer is the gelatin, but there are other possible stabilizers also. Amount is 0.2 to 0.5%. And fruits, in set yogurts, we don't add fruits, but in the processed yogurts, maybe 12 to 18% of fruits are there. But the thing is, you have to be very careful when you are using the fruits, because sometimes certain fruits, they are also acidic in nature, like pineapple. Acidic in nature. So then if you add into the yogurt, it produces more and more acid. So then it's the gas formations are there. So therefore the lid, so sometimes the bulging appearance is there. So then the shelf life is very less. So therefore if you can treat it with the sugar syrups like things, so then we can inactivate the enzyme, we can retard this growth of these other enzymatic reactions. So then we can increase the shelf life. So the different type of yogurts commercially available. One is called the low fat, no fat, creamy, drinking, flavored, bio yogurt. Maybe the probiotic organisms are there. Bio organic, milk and everything ingredients are organic. In the concentrated and frozen yogurts. Frozen yogurts are available now. Concentrated yogurts are there. Drinking yogurt. It's very similar to the stirred yogurt, but in the case of this agitation, agitation is severe. That's why I told you earlier also. Agitation is very severe. Total solid content not exceeding 11%. That solids are now 11. Flavoring and coloring are invariably added. Little reformation after packing. Even drinking yogurt, sometimes very little, but in the stirred yogurts, reformations are there. Frozen yogurts, having different recipes. Now you know that this frozen yogurts means yogurts are, we have to keep it in the freezer. Freezing is similar to the ice cream. So therefore the texture is influenced by the freezer. So therefore we have a different kind of stabilizers and emulsifiers are used for the frozen yogurt manufacturing process. I have done one experiment by using the ice cream stabilizers and emulsifiers. We incorporated into the yogurt, and then the yogurt, when you keep it in a freezing condition, so that we will have the very nice texture and the taste in the yogurt. But if you keep it in a chill condition, so you won't get the quality, proper quality. So that's the frozen yogurts. Now it's available in the market. Then another type of a yogurt is the concentrated yogurt. Concentrated yogurt, the coagulum break same as the stirred yogurt. Then concentration by boiling of some of the water. Once the coagulation is broken by stirring in the similar to the stirred yogurt, then the concentration by boiling. So of some water will remove it, but this is done under the vacuum. So we know that under vacuum, so we need a low temperature, so then we can evaporate some water. So then after that, strain or press the cooked yogurt. So then sometimes produce the rough or gritty texture, or sometimes it's called strain yogurts. So then we have the concentrated yogurt. Flavor of yogurts. Now this is the flavor, how this flavor comes in the yogurt. Because of this the different lactose, protein, fat metabolism, it produces different compounds like fatty acids, amino acids, lactic acids, carbon dioxide, acetic, diacetyl, acetaldehyde, alcohols, ketones, like many other compounds. Because of these compounds, the flavor is maybe the characteristics flavor is there in the yogurt, because the responsible compounds are I have mentioned this fatty acid to ketones. Now from the lactose metabolism, you can see this is the different kind of a compounds are for 6-phosphate, then the lactate, butanediol, ethanol, acetaldehyde are formed, diacetyls, different kind of flavors are formed. And lipid metabolism, yes, free fatty acids. So then keto acids, ketone, alcohols are produced. These are all flavor. Protein metabolism, yes, peptides, keto acids, amines, aldehydes are formed. So then you have the different flavor and the aroma. Now the manufacturing procedure is something similar to this curd, but the organism is different. In the curd manufacturing, we use the specific organisms, Leuconostoc and Cremoris-like organisms, Lactobacillus cremoris and things. But here the two organisms we used in the yogurt manufacturing process. So unit operations, we know that the clarification and other unit operations, standardization. So then after that, we have to use the stabilizers, and then the heat treatment is there. Heat treatment. So then the homogenization. So the incubation. Normally the incubation temperature is somewhere around 43 degrees. But until up to 0.6, 0.8, 1% lactic, we allow them to produce the up to 0.6, 0.8% of lactic. So then we'll stop the fermentation and we keep it in a refrigerated condition. Because these organisms are, two organisms are macroaerophilic organisms, And these organisms are thermobacterium organisms. Thermobacterium organisms. They have the ability to produce lactic till up to 3%. And they have the ideal temperatures, optimum temperature is somewhere around 40 degrees or 43 degrees. So that's why we have to provide 43 in the incubation. So they have the ability to produce up to 3% of lactate. Therefore, we have to prevent, or we have to avoid, so forming more and more lactic, and 2.5 to within 5 hours we stop fermentation by purposely, and then we just keep it in refrigerated conditions. So then we keep it in refrigerated during this 2 weeks time. Still the bacteria will produce little lactic, and once it reach to the levels, maybe around somewhere around 1.3 1.4 like levels, so then after 2 weeks time, so the yogurt will have the sour taste. That's by shelf life comes. Shelf life. So beyond that level, we cannot keep it for, because it gives them more sour taste. So then the additives and the packing and cooling. Now this is the way we produce it, and you can see the standardized milk is there. So we can have it to different fat levels. We can standardize. So then we have to provide the mixed preparations in the vat. We have to prepare the mixed preparations. So the milk powder, sugar, and gelatin. So then those are we can use milk powder also. Some people, what they do is they take the fresh milk and the milk powder also, then sugar, gelatin, and then filter. Then the storage vat, we have to add the colorings, and then the balance tag, then the pasteurizer, the plate heat exchanger. Then after the heating, preheating, homogenize. So then the homogenized milk will pasteurize, maybe 95 degrees. So then the storage, and somewhere around when it reached to this 43, 44, like 43. So we have to add the culture adding vats. Now it's cultures, we have to add it, and flavors, and then fill it into the cups, filling and sealing, and then incubation, somewhere around 44, 43, 2.5 hours, or maybe the 2.5 to 4-5 hours. That depends on the ability of these organisms to produce the pH. We have to check the pH reduction to up to 4.6, 4.7 level. We have to stop reactions. So because otherwise it form more and more lactic. So then we have to keep it in a refrigerated conditions. And so yogurt formation, so because of the yogurt, they improve the nutritional value. We know that microbes, because of the fermentation, and it makes firmer yogurt, improve the stability and ensure consistency of production, and increase the viscosity. So normally we have to take the milk, and then we have to increase the total solids up to the 16%, the total solids in the yogurt, or solids non-fat to 14%. There are different mechanisms. One is the evaporation of milk. While heating, we can evaporate moisture. So then we can increase TS, or we can add some skim milk powder, or we can add some lactose. Addition of milk concentrate, and then the addition of whey powder, addition of the ultrafiltration retentate from skim milk, addition of sodium caseinate powder, sugars and sweeteners. By having these different mechanisms, we can increase the TS and solid non-fat levels up to the 16% or 14. How we are going to reduce the fat? Reduce the fat, we can up to the 1.5. Sometimes we can add skim milk, or we can remove fat. We can remove. Sometimes if we can add water, not remove water, we can add water, right? We can add some water. So then we can reduce the fat levels. Now the sugars and the sweeteners are mainly the sucrose or the glucose, but normally we use the sucrose. Artificial sweetness also be possible for people, those who are suffering from these diabetic like things, right? So normally the sugar level should not exceed more than 10% prior to the incubation, because incubation, if you increase the more and more, then the microorganisms cannot survive because of the sugar concentration. So therefore we had to not more than 10% of the sugar prior to incubation. If it is more than 10, then it is adverse effect of the starter cultures. Higher levels should be added after, even if you, but normally we don't use the higher levels, but if you really want, so you can add it after the incubation, fermentation. Addition of sugar improve the body of the yogurt as well as the mouth feeling. Mouth feel. When you eat it, sometimes you feel some sort of a sensation is there, that is called the mouth feeling. As well as it will retain in your tongue for a while, then the body, because of the fat and the sugar TS will increase it. So then it's will retain in your tongue for a while. So then the body. Stabilizers, commonly used stabilizers are the gelatin. Even if you like, you can use pectin, agar, starch, or carboxymethyl cellulose, locust bean gum, guar gum, alginates, seaweed like this, whey protein concentrates, we can use as the stabilizers. Functions of the stabilizer is the hydrophilic colloids will bind the water, hydrophilic in nature. So therefore it will like to bind the more and more water, and consequently increase the viscosity of a yogurt because of the stabilizer. Help prevent the separation of whey. We know that whey separation sometimes we call syneresis. So it will prevent the separation. But the thing is, you have to be careful on the levels. Too much stabilizer gives rubbery texture. Far too much stabilizer gives the hard solid mass. If you use too much, then stabilizer, which will give the rubbery texture product. But if you use excess, more excess, far excess, far too much stabilizers, so then we'll have the hard solid mass. Now the two organisms are added. I told you that in the yogurt culture. So maybe the 1:1 ratio, and maybe 1 to 2% of starter culture be added into the yogurt manufacturing process. Now these two organisms are there. Now these two organisms they have the symbiotic action. Symbiotic action, not the parasitic, right? Not it's even the symbiotic. So both organisms live together, right? So then they grow independently. And out of these two organisms, one is the Streptococcus thermophilus, we call ST, and LB, Lactobacillus bulgaricus. ST grow faster. So their growth rate is faster than the LB. Grow faster, and as a result of that, they produce acids and carbon dioxides are produced. Acids are produced, like formate-like acids. So this formate and the carbon dioxide produced by Streptococcus thermophilus, ST, that will stimulate the growth of the LB organisms, Lactobacillus bulgaricus. Then what will happen now, when they start the growing of this LB produce, because LB produce stimulatory peptides and amino acids. So they will produce peptides and the amino acids because of the LB is the more proteolytic than the ST, more proteolytic. So therefore it produces peptides and amino acids. These peptides are amino acid for Streptococcus thermophilus, ST. So ST and LB ultimately form typical yogurt flavor and texture. These organisms have the ability to give the yogurt flavor. That's why it's a unique flavor is there in the yogurt. ST, because of the growth of this ST, it has the ability to reduce the pH up to 5. But Lactobacillus bulgaricus, they have the ability to decrease pH further to pH 4. So therefore, we have to be very careful. During the fermentation, 2.5 hours to within 4 or 5 hours, we have to stop the reaction, because otherwise the pH will gradually decrease it till up to 4. But we have to stop somewhere around 4.6 level, stop, and we keep it in refrigerated. At the time, lactic acids also may be 0.6, 0.8 to 1% maximum. The These are the fermentation products contribute the flavor. Lactic acids are there, acetic are formed, diacetyls are formed, acetaldehydes are formed, and then it gives the flavor that is the unique for this yogurt products. So those are the some of these flavors. Now you can see in this graph, so I have taken from this dairy processing handbook, and this is the step ST. ST is to grow faster than the LB. Now they grow faster, and they produce formic and carbon dioxide. Because of that, they stimulate the growth of the LB. Now LB's growth starts. Now LB starts, now it produces the peptides and amino acids. As a result of that, the starter culture growth is there. When you add the during that time, so we had only colony-forming units per gram. Log value is somewhere around 6, but now it's reached to somewhere around 8.5, 8 in between that because of the growth of the starter cultures. So then this pH in the milks, fresh milk is somewhere around 6.7, 6.8. Because of the lactic formation, now it's reduced till up to somewhere around 4 because of these two organisms. But during the fermentation, now this is the hours, incubation time in hours, this is the pH, but this value is the acetaldehyde. Acetaldehydes are in the blue color dotted line, acetaldehyde. So acetaldehyde initially very low, but gradually now it's increased up to the level somewhere around 10 or in between 10 to 100 ppm. Acetaldehyde levels are there. This should be 10. This 0, 1, 10 and 100 acetaldehyde. And this incubation is done with the 43 degrees centigrade and addition of 2.5% of starter culture. So the pH will decrease it and growth of the microorganisms and acetaldehyde formation is there in the yogurt culture, right? In the yogurt, the starter growth with the different changes of the pH as well as the formation of acetaldehyde and the growth of this starter culture. During the fermentation, normally we stop the fermentation somewhere around 2.5 hours. So at the time of this 2.5 or 3 sometimes. So at the time is the pH is somewhere around 4.6 or 4.6 level. So we have to stop maybe the fermentation, incubation. We have to stop it somewhere around in between 2.5 to 5 hours. Within that levels, we have to stop the fermentation. Now this is the network. I told you that because of this acid coagulation as well as the heat coagulation. So acid coagulation, now the caseins, micelles are there, caseins, because normally it is negatively charged, but now acids are formed. So then the aggregations, attractions are there. Whenever they attract, they entrap the fat globules. Fat globules are entrapped. So this is a yogurt network. If you can see the caseins are there, the proteins in between the fat are there. This is a network. Now this is the microscopic view. This is a transmission electron microscopic view. This is the scanning electron microscope. So you can see that when you have the scanning electron microscope, you can see the bacillus organism. And this is the Thermophilus, Streptococcus thermophilus. So this is the bacillus organism is there. This is the protein network. Protein gel network is there. Protein gel network. And you can see in the here, the fat globules are there. Network within that, fat globules are entrapped in that. So this is the microstructure. Packaging, storage, and distribution. So we know that this in the, especially in the yogurt, we use different cups, right? Not like the other bottles or other things. So here there's cups. Why? So this we know that is the mechanical damages can happen. So therefore, the shaking, tension, and pressure we have to avoid shaking, tension, and the pressure. If there is any mechanical damages, so then once the gel structure is broken, so it is irreversible. So therefore, you cannot convert into the initial 4. We have to avoid the mechanical shaking. We have to prevent the light penetration. We have to prevent oxygen penetrations. Then we have to control the temperature. So then only the internal composition, nutritional as well as the microorganisms may be there. Otherwise, the different reactions can happen because of the light, because of the high temperatures, or the oxygen, or the mechanical shaking. So then, if you can maintain these things, so you will have the very good quality yogurt. Now, this is the SLS guidelines in the yogurt. So we call as the normal yogurt. The minimum fat is 3%, and there's another one that is we call as the low fat yogurt. The fat content is 0.5 to 3%, low fat. Non-fat, even though we call as non-fat, the maximum fat is 0.5%, non-fat. Non-fat, low fat yogurt, normal yogurt. 3 maximum, 0.5 to 3, less than 0.5. Drinking yogurt, the fat percentage is minimum 2.2. If you wish, you can have the more. Milk solid non-fat is yogurt, low fat and non-fat 8%, but the drinking yogurt less, it's 6. Milk protein should be there in the 2.7 in all products. pH is 4.5, the maximum pH 4.5. So again, the microbiological limits are there. Coliform, Staph aureus, yeast and molds, 3-class attribute plant. But in the Escherichia coli, E. coli, Salmonella, Listeria, monocytogen should be absent in a product. So after making the yogurt, even if you prepare in a quality manner, so there are some quality defects may be there as far as the appearance and the texture is concerned. Appearance and the texture is concerned. But first defect is the syneresis or way separations. Syneresis or way separations can happen. That is because of the low total solids. I mentioned about the 16 to 18% of total solid should be there, but the total solid content low, then syneresis can happen. Over acidification, over acidified it because of the starter cultures or higher incubation time, or mechanical shaking of gel network. If somebody is shaking the yogurt cups, so then the mechanical damage is there. Insufficient denaturation of whey proteins. Insufficient denaturation of whey proteins because of the improper heat treatments. Incompatibility of dairy and non-dairy ingredients. We use some stabilizers, dairy as well as the non-dairy ingredients. That is incompatibility. Too high incubation temperatures. Incubation temperature, not the 43, maybe high temperatures. Or sometimes the too low acidification. pH is greater than 4.6 even. Low acidifications also cause the syneresis. Sometimes the low viscosity of the runny, we call runny. The low total solids, insufficient heat treatment, or homogenization of milk, then low viscosity. Poor selection of stabilizers. So stabilizers, the poor selection, not a good quality stabilizers. Too low incubation temperature. Low temperatures, ideal 43, but low incubation temperature. Or too low inoculation rates. Sometimes we have to use the 2 organisms, ST and LB 1:1, maybe 2% of that, but too low, so then it causes the problem. Film or colony growth on surface of consumer packs. Films are there, or colony growth. Growth of the yeast and molds. Yeast and mold growth can happen because of the poor pasteurization or the heat treatment, or sometimes the contaminations, or unhygienic processing conditions in the factory. Small scale farmers, sometimes unhygienic conditions are there, then the growth is there, film or colony growth. Long or ropey texture. That means the slime producing contaminants are there. Slime producing contaminants are there. So therefore, because of this, the long or ropey texture is there, or too low temperature of incubation, then the ropey texture is there. Sometimes the quality defects we call as the, even in the appearance and texture, grainy texture, grainy texture, just like a small grains like things, the texture. Improper mixing or homogenization of dry milk ingredients. Yes, milk, some people they use the milk powder and then add the water, the reconstitution, but during the reconstitution, so sometimes the milk powder will not dissolve properly. So the grain texture is there. Too high incubation temperature and too low inoculation rates are responsible for the grainy texture. Mealy glue texture, excessive addition of milk powder. So mealy glue texture. Gas or air bubbles in coagulum, gas bubbles. We know that this gas bubbles comes because of this contamination with the E. coli, sorry, not E. coli, coliform, sorry, coliform is the, we know that the gas producing organism, lactose fermenters and gas producers, yeast or coliforms, or sometimes the aeration during pumping because of these air leaks in pipelines, the continuous production. So if there is any leaks, so then the air bubbles incorporated into that and this appears the gas bubbles. Nodulation of curdy flakes, improper mixing of starter cultures. Starter culture is not properly mixed. Then the localized fermentation. If the starter cultures are in a particular place, then if that particular place the fermentation is taken place. That's localized fermentation. Too rapid acidification is another problem for the nodulations. So then the flavor and taste, the quality defects. Now this is the flavor and taste. Unclean or low acidic flavor is there. Poor activity of starter culture. We know that sometimes the yogurt manufacturing process, the starter cultures we use as the bulk cultures, but time to time their activity will reduce it. So therefore, time to time we have to use the proper starter cultures, replace from that. So then we have the activity, we can maintain it. Otherwise, if the poor activity, then unclean or low acidic, fermented flavor or taste is there, that the contamination by yeast and coliforms, high acid flavor, sometimes high acid, too rapid fermentation by starter culture due to high temperature or too high starter concentration levels. Amount of concentration, the levels, the starter culture is high, or sometimes high temperature fermentations. So then because of that, too rapid fermentation is there, then high acid flavors are formed. Grazy or feed flavors, because of this the flavors comes from the raw milk. So that is the feed especially. So if the animal fed with the grasses or the other feed which having the different flavors, so then it comes to the milk and finally it comes to the product. Bitter taste, high proteolytic activity, too high starter inoculations. Yes, proteolytic is the LB organism is high proteolytic. Peptides are 4, then it's bitter taste. So that's why 1:1 ratio we had to add it. If sometimes if you use more LB and less SG, so then more proteolytic. So bitter taste. Rancid flavor. Fat degradation due to lipolytic enzymes. So lipolytic or lipases like enzymes, so during the heat treatment we can inactivate. But insufficient heat treatment, sometimes it causes the enzymes may be present. As a result of that, it will fat degrade and easily rancid. Oxidize because of the metal catalyst or the light. That's why we have to prevent the light penetration of light. Then the metal catalyst, we have to prevent that. Now this is the heat treatment for cultured milk in the production line. So milk, so then this preheating, so the cooling. Now we have the balance tank, then the plate heat exchanger. So then we have to heat the milk and deaeration, evaporation, and then again the milk will send it to the homogenization and heating and holding. Heating and holding this milk. Holding. And then after that process, now this is the first step. So this is the bulk starter tanks. So we add the starter cultures. So then the incubation is happened. So then the cooling. during the incubation, the cooling. And then after that, the buffer tank. So we had some fruits or the flavors, we can mix it if you like it. So then the packaging is done. Okay,